made something that looked quite impossible just last week, as you can see, perfectly possible. And so we're delighted to have Fernand with us. Katja was just asking me how long we've known each other. We've known each other forever, actually for half a century, almost.
What?
Right? Almost half a century. We were undergraduates in this institution at the same time, but I was more clever. I was clever.
Absolutely, yes.
He actually had he walked away with the President's Cup. Yeah.
You had to pay a lot of money for it.
when he graduated. So he did his undergraduate degree here in physics at AUC, and then his master's and PhD in electrical engineering at Brown University. Fernand joined the Department of Electrical Engineering at the University of Rhode Island in 1983 as an assistant professor, and in 1984 he joined the Robotics Research Center, University of Rhode Island, and was responsible for the vision research in the center from 1986 to 1987. In 1985, he was the recipient of the Research Excellence Award from the College of Engineering, University of Rhode Island. He was in 1986 invited by the French government, Mission Scientifique, to tour research laboratories and universities. In 1987, he joined the Department of Electrical and Computer Engineering at Drexel University as a named chair associate professor. He is currently professor of electrical and computer engineering and is affiliated with the School of Biomedical Engineering, Science and Health Systems, and serves as director of the Imaging and Computer Vision Center. The rest of this introduction includes many things I really don't understand. I even thought that there were typos left across the words. I'm hearing for the first time, but I'm sure that Fernand will come up in his talk. I just want to say that he is very, very widely published in more than 130 journals. His most recent projects are computational archaeology and person recognition and tracking in crowded scenes. Is it infra or infarction?
Infarction, yeah, that's heart attack.
Do you know what that means, infarction?
Yeah.
I don't know what infarction means. I thought it was a typo. Infarction detection from ultrasound and image-based non-GPS navigation. He was keynote speaker at many conferences, more recently in Bangkok, Barcelona, and Morocco. His research interests include pattern recognition, computer vision, medical image processing, computational methods, sensor networks, and applied stochastic processes. Voilà. And so I'm delighted that Fernand came all the way from the US to lecture today on the challenges of machine translation, cultural machine translation. So,
thank you so much.
Thank you.
Well, it's always a pleasure to be back to a place where I started as a student, and to see my esteemed professor. Thank you, Nick, for coming, Feriel, and thank you, Samia, Mark, and Steve, for making it possible for me to be here and to share with you what we have done on machine translation. It is a work in progress, as they say, a challenging one for that matter, but quite interesting nonetheless. Let me start. Oh no, I have to move the other one. By telling you a story. It's a non-anecdotal, unfortunately, about the late 80s, where my late wife, Magda, just graduated from Harvard, went to Princeton, and she was asked to review a translation of an Egyptian novel from Arabic to English. And this is from an academic professor in a very prestigious university. I will not name anybody. And this is a passage from that book. and then we will see what the translation came to be. But what is important here is in this one, in the late 80s, for that person, Jalabeya was the problem. So Jalabeya is, of course, a woman dress, but it is a popular attire in the Arab world, where you can wear it as a pajama or wear it as an attire that you can go out with. But that person, unfortunately, took it as a woman dress, and that was the English translation, where the intent was definitely not that he was a cross-dresser taking advantage of his wife being away, closing his door, and exercising his cross-dressing. It is laughable, but it is true, unfortunately. And this is from somebody who is in the field, who taught their students Arabic novel in translation. So this is, I mean, it's definitely an honest mistake, but definitely not the intent of the book and not the intent of the original text. And therefore, what really this example shows, and there are so many of them, is that when we do translation, whether it is human translation and even more so machine translation, we have to be aware of the cultural context of what these words mean, or else we'll be ending up with a translation that is absolutely erroneous and meaningless. So that brings me to what is the biggest challenge for machine translation, to an extent also for human translation, but for definitely machine translation. And the biggest challenge is to really catch up on the nuances of what is said or written, and to be able to express it faithfully in the language that it is you're translating the text into. And at the core of the problem, what it is not, I should say, what it is not, is a literal translation word by word. That is not really what machine translation, human translation is all about. You have to understand and put yourself in the context and in the culture itself to be able to have a successful translation. So what happens, I mean, what is the main problem associated with the not getting a true translation is polysemy. You have a word that could mean different things and a text that has a subtext. And unless you get to the right subtext, you are bound not to succeed in your translation. So what are the sources of polysemy? There are a few. There is slang, there is dialect, there is cultural hegemony, there are stereotypes, and that's another thing that one has to be very aware of, and that who is doing the translation. So basically, if I go for an expert, that expert has an agenda, whether a political agenda or otherwise, then he or she are no longer experts. They are enforcing what they want to portray the translated text as, rather than the intent of the author of the original text. So that brings me back to, where does machine translation, where is that success? And for simple text, machine translation has been very good. I was recently in Spain, and I went into a cafe, and since I look Portuguese, and I look Italian, and I look many things, Italian, Arab, and everything else, they gave me, no, not Indian, this is the response to you, but anyway, they gave me a menu which was in Portuguese. And of course, I could not understand the word. I don't speak Portuguese or Spanish. So what I had to do is, I had internet connection, got my Google translation, and things that I was going to order because I thought they were one thing, turns out to be snails, and no, thank you very much, didn't order it, and moved on. And this is one example of where machine translation has been quite successful, actually. When you want directions, where you have signs, simple things. Now, where does machine translation falls on its face is when you start dealing with nuanced text, and not very complicated or not very ambiguous for that matter. So let's look at the next example. So let me just move this one to be in sync. So if I look at this sentences in English, during their last night in Lisbon, they passed the port at midnight in the pub. And I want to translate that into French, which is a cousin language, although one is Germanic, the other one is from the Romance, but they have a lot of commonality in terms of the words. And then if you look at the translation here, not only it doesn't make sense syntactically, it is incorrect. Au cours de leur dernière nuit à Lisbonne, ils ont passé le port à minuit de Saint-Cloud. As if the pub is a moving vehicle that passes by the port, which is absolutely ridiculous. Now, what is the problem associated with that? The problem associated with that is port has different meaning. Port could be a harbor, could be a interface, a circuit interface, or if you are attuned to the culture of where you are, it's a Portuguese wine. So basically, the intent of that sentence is what you see next, which is a paraphrasing of that sentence, is they handed in the bottle of wine from one to another at midnight in a pub in Lisbon. If you give this to Google Translate, it will come up, it spits out the right translation. But if you give it the original text, it goes somewhere else. So what do we learn from that? What we learn from that is it is important when you're doing machine translation to be able to key in on keywords that will make the probability of picking one. You have an ambiguous word that can take various values. To pick the right one with the highest probability based on this keyword that helps you out. So if I look in here, I say, what are the keywords? I would say Lisbon, pub, midnight. These are keys to tell me that the selection of wine as the input is the one that I should pick, and not a circuit interface or a harbor for that matter. So that brings us to where do we go with that as in the background. And what we have tried to do is to come up with a language model that takes into account those keywords, dependency, and builds a probability, conditional probabilities of what is the state of a word, an ambiguous word, given the state of the words that are keywords. And I'm going to try as much as I can to minimize the science and give you the gist of what we're trying to do. So if you see equation, I will explain things. These are for me to remember that I need to do an explanation here, not for you to decipher. And just to situate our work in machine translation, there is a huge thrust in disambiguation of words, whether in a sentence or a paragraph or a page. And by and large, there are two distinct methods for doing that. One is what's called deep learning, using neural network, which learn basically in layman language. You give me lots of examples, and I learn from them and come up with this structure of the black box that align these neurons inside. So next time you give me an example, I have learned from before and can do a right classification, hopefully. The other one is a model-based, a statistical model-based, whereby you go into constructing models that explain those dependency between ambiguous words and their neighbors, whether the neighbors are spatial, defined in terms of spatial proximity, or they are defined in terms of semantic proximity, keywords, in other words. So there is also a thrust in researching paraphrasing, and I'll give you an example of ports and how the paraphrasing helped in getting a correct translation. And then there is alignment between bytext. So you have two texts and you try to align things and do the classification and the alignment all in one, the translation and the alignment.
What's alignment?
I beg your pardon?
What's alignment?
It's, you say this word and this word, this is the verb, they should be aligned, etc. So that's the alignment. Our work, what I'm going to present today, will be on word disambiguation, so just to situate what my talk is, and using model-based. And I'm going to give you arguments and show you results as to why model-based is superior to deep learning, learning from experience, or from examples, basically. Now, our contribution insofar as this talk is concerned are basically four things, and I'll try to, as much as I can, go through all of them. One of them is to come up with that language model where I am going to look at words as nodes, and the chain or the interaction between those nodes tells me how much dependency or non-dependency there is between that node and other nodes in the sentence. So for example, when I took the example of the port, so you have port, Lisbon, you have midnight, what are those interdependency, and how, if I have one ambiguous word that I want to decide on its state, what is the probability given the state of the others being fixed? And I get this graph, the semantic graph that I'm going to build up, which leads to probabilities that are parametric probabilities. I will estimate the parameters from the data from parallel bilingual corpora, and that will be my starting point, not the ending point, because I definitely would need the expert opinion, meaning, first of all, parallel corpora are limited, so you don't have that much of it. Secondly, the use of the language is a dynamic process. And things that, especially if you use slang, were not used 20 years ago. Now they are by the new generation, and therefore machine learning that does not have access to this new update will give you the erroneous translation. So there should be always a loop where the expert comes in and updates your knowledge about the model parameters. Clear? Okay. I will also try to show you how one can disambiguate sentences that have more than one word with more than one meaning, and come up with a fast way of finding the most likely for both of them, or for the three of them, the most likely states of all of them. And then finally, through experiment and also an argument, I will tell you why I think model-based is superior to neural network, in particular when data is limited. So you don't have too many examples to learn from, or updated examples to learn from. Okay. So I'll start with the semantic graph, and since I was a physics major at AUC, it had to be physics-based, and this is the Gibbs model. But it doesn't matter what it is, let me proceed. So, for some of you who do not know what conditional probability is, It's a measure that tells you what is the probability of an event B occurring when an event A had occurred. Basically, in a very simple layman language. So, in the example that I gave, what is the probability that port will be a harbor given the midnight past Lisbon that had been already translated in a certain manner? Well, okay. So, on this, so I'll take this sentence. Each of the words is a node. So it's a node that has different states. And the states are, for the port, would be harbor, hardware interface, Portuguese wine. So the first thing one would say is, how about if I consider spatial proximity? And the idea of spatial proximity would be, you know, the words that are adjacent to the word that you want to disambiguate will have the biggest influence. So in that case, I would say, okay, so what are the first neighbors of the word port? It's the, at, and the second neighbor, you add past and midnight. So if I look, and I'm going to say, what is the probability of port being harbor given the 8 if you're stuck to first neighbor, or if you're enlarging it to second neighbor, what is the probability it will take if it will be past the at midnight, etc. What am I?
Semantic. Go back semantic.
Yeah, I don't know what happened. There was probability that disappeared. Let me see if I have it here. Anyway, so I'll make the point, it doesn't matter. There were things that would show you. So, for instance, if I look at what is the conditional probability of port given the and at, it will be same likelihood, same probability if you pick hardware, if you pick hardware interface, or you pick Portuguese wine.
I think that was there, the 0.33, right?
Yeah.
That
Oh, there was that 0.33?
Yeah.
I didn't see
Yeah.
that.
The fine line.
Oh, thank you. From that, yeah, okay. So you could see, it doesn't tell you much. It does not disambiguate, it tells you it's all likely. If I were to increase the spatial proximity to second neighbors, then yeah, I could see that interface at midnight, in port interface, circuit interface is less likely, and it will be almost the same whether you consider hardware or wine. So the idea here is, I don't want just spatial proximity. I should go and seek keywords. And the keywords need not be just adjacent to the word in question. So in that case, if I look at first order, which would be Lisbon, midnight, and second order I add a pub, then the probability will change drastically now. So if I look first order only, which is Lisbon at midnight, well, it's harbor and wine will have almost same probability, and interface will go even down, more down. On the other hand, the minute I add Lisbon, then it tells me you're in a pub, you're in Lisbon, you're at midnight. What do you think the probability of it being a harbor versus it being Portuguese wine? And the probability will be in favor of the wine. Not that you are 100% sure, but at least you could see what the mindset is. So the whole idea is get the semantic graph, model this probability in terms of parameters, the parametric probability distribution, estimate them from parallel corpora, so that next time I give you a text, you have this estimator and you do a classification based on what is the most likely scenario. And again, it can be that there are scenarios that the probability are very close, and the need of an expert to come in and have an interface with that is of great importance, because the expert has updated information, and of course I'm going with the assumption here that the expert is unbiased, no political agenda. So one way of combating that is to have many experts and then do kind of weighted average. If you know somebody has a political agenda, you give it a lot of smaller weight than others, etc. But that's the idea. So that Gibbs model is described in terms of conditional probability, and let me just explain a few things. XR is the word will be port, for instance, and given all the words in the text will only depend on a set of keywords, which are called V, in a neighborhood. So you say first order, second order, like I gave you those examples. And the whole probability of the text is a product of this conditional probability. So that's, you go and model this conditional probability, and then you have the probability of the whole text taking a certain translation, a given translation versus others, and you always go for the ones that gives you the highest probability. And then also how much higher than other states gives you an idea whether this text is nuanced and still ambiguous, or the difference is so huge, then you go with one state versus another. So this is an example of one example of the model structure, and let me just explain briefly what it means. It means I'm looking at XR taking the state K, which is, for instance, port taking harbor or port taking Portuguese wine. And there is a parameter that tells you how much of the interaction between these two. Port being the state harbor and its neighbor, the neighbors, the key neighbors. And then you can talk about triplets. Instead of just pairwise interaction, you can talk about triplet interaction, four at a time interaction, and so on. So it's rich. So the conclusion is that the joint probability is a parametric distribution, fully expressed in terms of these zeta parameters that you can get efficient estimators for. Efficient in the sense of you can get the ones, I can guarantee you getting the one that has minimum variance. So this is maximum likelihood estimator. Just saying that they are very good estimators, the best there is in the market, let's say. And it gives you, it attains the bound, which is the lower bound that an estimator can attain for these parameters. And as I said, they are estimated from parallel corpora, bilingual corpora. Okay. Now if I look for this model, these parameters are basically the log of the frequency of occurrence of a port taking the value harbor given the neighbors relative to the occurrence of the neighbor, the keyword, and X being port. So how many times did you encounter port taking the value harbor given its neighbor versus how many times in the text did you encounter the pair harbor and the keyword? So it is based on frequency of occurrence, which is attractive in that sense, and the maximum likelihood estimator is just the log of that. This also can give me, because the frequency of occurrence, it gives me a sense of how I can put weight on what keyword is more important than others. And basically, I can say the one that has highest frequency of occurrence will be considered a first neighbor, not spatial proximity, semantic proximity, and then the second, etc. And where do I cut it? I cut it where this frequency of occurrence becomes so small that is below a certain threshold, and I say that's enough. I'm only needing 10 keywords, not 15, not 20, because the dependency of this frequency of occurrence becoming smaller and smaller and smaller, negligible kind of thing. Okay. Now that moves me to the second part, which is how do I incorporate the expert opinion to update these parameters that were giving me the classification of the model. Now, first of all, why do I need it? And I said that already. I don't have, it could be sparse data, I don't have too much example to learn from, or parallel corpora. It is expensive to manually target data, basically say this word is this word in translation, this word is this word. It's an expensive process, secondly. And thirdly, as I said, it's a dynamic. It's a dynamic process where words that meant something 10 years ago are used differently now, and you need an update. So what to do? Seek the expert. So the idea of using an expert is to say, okay, experts are not computer scientists or engineers. They are you. So what we need to do is have a GUI or a system which is very friendly, where an expert can come in. I present a sentence with words and say, tell me, what is your belief from 0 to 1 or from 0 to 10 as to what the state of that word should be? So you come in and say, you know, it should be wine with, are you sure? Yeah, 8 out of 10 I'm sure, kind of thing. And how about it being harbor? Oh, maybe 1 out of 10. So I form that space where there are those probabilities that will sum up to 1. And then based on it, I would say I take that and translate it into these parameters that are the log of the frequency of occurrence. So if it says 0.8, it will be the log of 0.8 to take harbor or to take wine. And then what I do is take my parameters that I were obtained from the corpora and update them with the expert opinion or expert's opinion, if I take the average, and then have weights. It's a linear combination of both. And depending on how sure the experts are, if the experts are extremely sure, then this will be driving the updates. If the expert is not, so it's a combination between your prior, which is the feedback of the expert, and what the data is telling you. And then you update, and these will be the parameter that will be used next time you give me a sentence, and you tell me what is the likelihood of a word, ambiguous word, taking one value, another value, or a third value. Forget about that. It's just a linear combination between the one you got from the maximum likelihood. Yes?
So can I just ask, this expert belief, does that feed into the next time that word is encountered, or is that only for settling like one-off?
No, yeah, of course. I mean, what you try to do is, it's not for the text that you're learning from, but for something that you are going to encounter later on.
Yeah.
Yes, because that's it. If with regard to the text, you already have a classification by the expert. And if the expert is telling you with high probability, it will trump what you had a priori. But the importance is not for the current one that you're learning from, subsequent ones. So all this says is that you have the data-driven part, you have the expert, and it's a linear combination of both, and the weight associated with them. So that brings me to the third part of my talk, and that is, what do you do when you have more than one ambiguous word in a sentence, and you have to resolve both of them simultaneously, and you want to do it efficiently? And we come up with what's called the relaxation method that does exactly that. And I'm going to explain what is that relaxation method. It has nothing to do with massages or anything, as you can see. So consider this sentence. Provisions address children education to prevent the problem. Now, provision can take few meanings, and address also takes few meanings. So now, I want to decide on provision, given keywords. So you have decided what keywords, and address is a keyword for provision, and provision is a keyword for address. So you have this ambiguity, so you have to decide on one of them to be able to decide on the other with this conditional probability of B given A, right? So what we do is, so here supplies and rules, address will be given that you, for instance, fix the address, and let me go one more. So it's location or deal with. Right? I mean, if I ask you, it will be what? Supplies, not location, of course, deal with children education to prevent. Right? So that would be what you would think the translation should be. So if I want provision and I have to fix address because it's one of the keywords, and I can pick either location or deal with as a start. Then I compute the probability of provision being supplies and being rules, given that address was deal with or location, and then revisit in the next stage of the relaxation and see if the probability of them jointly is increasing or is getting lower. If it's increasing, then I keep on changing until I converge. So that is the whole idea. So let's go through that so you can see what's going. So here, I want to look at what is the probability of provision equal supplies given address as a location, education, and problem. And that is 0.66. So I say, okay, that's good. Now let me see if I'm going to go and change location into deal with or change provision into rules. Are they going to change or not? Is it going to increase? And you can see here the probability of address deal with given provision equals supply education is 0.83. Then I go through another iteration, and the third iteration, provision is rule, address, so I keep on changing. And then that probability, and then finally, the combination address deal with provision equal rules education is the highest one. Then I would say this is what I'm going to settle on. And it's done very quickly, yes.
I'm sorry, is there no syntactic disambiguation because such a sentence would have to have a verb and
Correct.
then address would be disambiguated right away?
Yes, but I can also give you other examples where, like in the port, for instance, for all of them. So syntax does not help you in this situation, right?
But would the program do both the syntactic and the semantic as well?
Yes, absolutely. In general, what you need to do is combine syntax, semantics, cultural background, all in one to help you out disambiguate words. This talk is like more concentrated towards the cultural one as to what is and what is not relevant information for the disambiguation. So now I'm going to come to the experiment, and we have two sets of experiments. One is on medical data, and the other one is on basically articles. This is a joint work with my Chinese graduate student, and therefore everything is Chinese. I try to steer them or steer him to do Arabic, and I don't think it's a good idea. But this is something that is definitely, in terms of the basis, it applies to any two languages. It will have peculiarity based on the language, but by and large, it's the same idea, the same framework. So we did two things. We have to have learning and then classification. And we did two methods. Leave one out is basically I have 100 sentences where that word came in, and I took 99 of them at random and picked one for classification, 99 for learning. And I learned all these parameters that I was talking about. And the other one is shuffle split. So basically, I take, out of those 100, I take 50 cases and use 80 of them for learning and 20% for classification. Now, the reason we did that is to see how is the neural network, which is deep learning, compared to our method. This will be when they have more data to learn from, because they have 99 cases for classifying one case, and then you do, of course, random selection. You get another 99 and 1, another 99 and 1, etc. versus you learn from 80 and classify 20. So let's look at, with the medical database, that's a much easier scenario. You don't have disambiguation that much. The second order and the third order clique, our method is 96% and 97%, around 96%. And the neural network is 84. That's based on leave one out. If I go and do the shuffle and split, which has less data points for the neural network, our method, which is based on the model, is the same performance, whereas the neural network performance goes down. It's only 79%. Now, I wish that was the nice scenario when I talk about narrative, which are not in the medical field. Now, so literary fiction data sets, if you want, up to a third order is 71. I'll leave this for a second. And the neural network is 65. This is for the leave one out scenario. So it's still better than the neural network, but it's around 70%, it's not 93%. However, the minute I get expert opinion, that classification where it is a combination of what I learned from the data and adding the expert opinion jumps the classification to 93%, which tells you that having an expert in the loop is extremely important for improving your disambiguation. For the shuffle split, about the same performance for the model, but the neural network went down to 60%. It's even worse than 60, it was 69, now it's even worse. And with the expert, it's still 93%. The combination of the expert and the data driven. So in summary, we're getting to the end of it. What we have done is to come up with a probabilistic language model based on semantic graph to disambiguate words, based on keywords, not necessarily based on spatial proximity. Secondly, we have introduced a user-friendly framework whereby an expert who is not necessarily a scientist, I mean an engineer or a computer science, can come in, give us their belief for the learning, and we translate that into engineering language and the parameter for the model to update what the parameter should be, and which led to a better classification. Thirdly, we came up with a iterative relaxation procedure to disambiguate sentences which has more than one disambiguous word. So go through the iteration into conversions, and then finally show the model that the model base is stable, whereas the neural network is very much a function of how many examples you have to learn from. And that leads me to the conclusion. And the conclusion is that until a machine translation becomes sensitive to the cultural understanding of what is written or spoken, translation will remain a mechanism that reinforces pre-existing stereotype, misconception, and misreading in defining the other. And that, I will stop.
Thank you, Fernand. This is a tough one. A lot of concentration.
Oh boy.
Well, I'll let you run the show. I'm sure people have questions.
Yes.
Go ahead. My question is very simple. Yours probably is more.
Your question is, I've never said.
Mine is just a question about the kind of real-world ramifications of this research, because take, for example, Google Translate, which I imagine is the most commonly used machine translation. Mm-hmm. It's still just catastrophic for Arabic, which I think is, if I've understood correctly, is probably a function of the fact that there aren't very good corpuses for Arabic, and Arabic has various other challenges. Mm-hmm. I presume there's also a fairly major gap between the kind of cutting-edge research that you're doing and its commercial launch. Mm-hmm. So I'm kind of interested to know what what that gap is?
Well, I can tell you the following.
Yeah.
Google is really open to any research that will improve the translation. That means they are willing to sponsor your research and have it translated in terms of a product that Google has. So until they get in touch with a huge grant, they will not get it. but no, on a serious note, I think the more of a concentrated effort along those lines starts everywhere, and they have started, the better the Google Translate will improve. And it's not just Google Translate, there's the European one, which is far better, and they take into consideration things that Google Translate doesn't really.
What's that called?
I don't have the, but I can find out for you. Yes. So basically, the people did not start thinking in terms of cultural translation is important. Culture is important, and there was like the advent of translation was based on basically the idea of you can look at the syntax, and that will give you the right translation. And it is no, it isn't. It is not just the syntax alone. It's more than that. And those efforts are feeding into taking into consideration that.
So is the semantic proximity factor the main innovation that's addressing this cultural problem?
Absolutely, yes. Yeah. And coming up with those models, those probabilistic models.
How much do you feed? I mean, it seems to me that you, in order to you have to have a corpus. And so this is endless. It seems to me it's endless, especially that you already know that language is fluid, it's forever changing. You need an expert all the time.
So I'm a tool. You are the expert. So it means I'm given corpora up to now, right? Now you, as a community of translators, it behooves you to come in and say, yeah, here is my input, and so I can update that in the absence of a new corpora coming in, bilingual corpora, or parallel bilingual corpora. So I can't do that as a computer scientist or an engineer without you. I am your tool, kind of thing. So until you feel the necessity of doing that, there will be a limit as to and a speed of progress.
Well, what kind of size of corpus are you using for research like this? Like how many?
The one that we used, there is a Beijing corpora that is done in extensive, and there is also a Brown, another one, and it is an extensive one, but it is old, so it's like 10, 15 years old. So it is what it is. It is not bad. They went through the sweating process of getting it, but nonetheless, it is old. And until there is a push, politically and otherwise, from your community as to the importance of having the expert updating those corpora or getting involved in something friendly, GUI kind of thing, the state of the art is not going to be more than what we had 15 or 10 years ago. So that is the best bet I have. Another question that one has is gold standard. I do a lot of work on biomedical imaging, and for cancer detection, for example. And there is the gold standard. What is the gold standard? It's biopsy. It is not the radiologist that will make the decision. At the end, you have the biopsy that you can compare it to. What is the gold standard in translation? That is the problem here. Because if I am biased, that's not the gold standard. I'm not taking you as the one. So again, it behooves you as a community to stand and say, this is what we consider the gold standard. These are the ones that are unbiased and really giving you what the translation should be without any agenda, political agenda that is driving it or driving it.
I have two
questions. One of them is you can translate something by giving it to a translator.
Correct.
And you can translate it with a machine. Okay? In what field do they use the machine translation? And is it really, economically viable to do all this work and all this research and program it and bring the linguists and bring I don't know what and so on? I mean, especially that you tell me that it's culturally sensitive, you know, and culture is not only culture, culture keeps changing, you know. So that's one question, you know, I mean, the economic aspect of it and who uses it and so on. The second question is, when we have a name, a proper name, for example, Jamil or Samia, does the machine knows this is a proper name and doesn't translate it? You know, I mean, there are certain things we don't translate. I mean, we say Samia, actually there was someone who was translating Nabi Mahfouz, and there was a character called El Gindi, and he translated into soldier. But that was his last name, you know. So does the machine distinguish between proper names and other things? Proper names can have meaning, you know, but they're not translated.
The machine is not a, there is artificial intelligence, meaning learning on its own after giving a few examples, but it is not a magician. So that means what do you do at the learning end will be what you will get at the end product in terms of classification. So when you're saying economically, yeah, sure, economically it will be very economical to have the machine translation, in particular in the business field, where you are doing a multi-million-dollar venture, and reading something wrongly can lead to disaster in terms of taking a text and reading it in the way it should have not been read, and then make a decision, a business decision based on that. Now, and I see that a lot in the States, you have people who are not the expert, and even the experts, like the example I gave, are giving wrong translation. So if you have a machine that is really have made use of a lot of learning and have been updated, then the likelihood of it coming up with the right translation would be more likely and higher than somebody that are claiming themselves to be an expert when they are not. So you have a kind of an average effect. Yeah, will the machine replace an expert, the translator? I would say no, but it depends on the expert. If you're talking about a horrible expert, yeah, I want the machine to replace them, for sure.
But when the machine does the translation, I mean, I have a friend who is French, you know, when he goes to conferences, he's really English speaking, or German speaking or something. So he writes it, and then it gets translated, and then he goes over it. So is it like this in all machine translation, that somebody has to go over it, make sure it didn't make a terrible mistake or something?
No, it isn't like that.
So you just take it and send it to its address or something?
Yeah, you want to...
I think the way that currently these things are used most commonly is in the form of these things called cat tools, which are things like Trados, MemoQ, which are like user-friendly programs individual translators can use. And most people tend to use them, or most translators who use them do exactly that. They review them. They will build, as they're working, create their own corpus based on the text that they've translated, and then they will always edit it. You can never just feed it a text. Obviously, that's not necessarily how it would work in the ideal with this research that you've been doing.
I mean, it could be. It depends on what stage you're at in terms of the development. If it's in infancy and you're still learning, then it's not wise to take it as is and put it in there. But what it also gives you an idea on, from a machine point of view, is a method to tell you what are the important keywords, for instance. What are the cues that reveal to you a translation X versus translation Y? Which you will be a good translator is doing it even without thinking. So having a machine doing it in terms of time, if it's doing the correct job in terms of time-wise, it's instantaneous.
but it's also disastrous.
Could
I
be.
mean, you know.
Oh, absolutely.
Yeah, I mean, when you
So how are all these things factored in, and how to what extent is it possible to establish like a numeric representation of all these?
Remember the slide where I had the ranking of what are the first of all, what are the keywords and the ranking of them. That feeds a little bit into your question, in the sense of, here is a way of saying, you know, I consider there are many words. Which one would you consider as keywords? Like, if you're talking about gender, which words are going to, what words are going to be key to understanding of that you are looking at a certain genre versus another one? That's one. Secondly, if you're going to rank them, you're not going to have a condition on all the words in the world, but you are going to have to rank them. And that slide showed how you can rank them in terms of frequency of occurrences kind of thing. How many times do they occur jointly, and how many times out of these it takes a particular meaning for the word that you want to disambiguate. So at least there is, I'm not saying that it answers everything, but at least there is a method as to the ranking and the selection of the keywords based on the context. Yes?
I was interested toward the end of the talk. Where
you were sleeping there before that?
I woke up.
Okay, great. Thank you.
You were evaluating your two approaches. And you were getting, when you added the experts, 96, 97% success rate. I mean, that's fantastic.
Right.
But I'm really curious about the 3% or the 4% that weren't captured by the model. Would that be a way also of improving how you were doing, to really study the cases that escaped you?
It also tells you something about the expert choice, meaning. In the selection, we in one of the experiments we had Chinese graduate students, and some of them were first-year graduate students, some of them were fifth-year graduate students, for instance, and their command of English is definitely different, and therefore, so the selection of the expert is important, but it is not for me to say who is a good expert or who's not. This is something that you guys should decide on. But once you have decided that, it will be of great benefit for machine translation in terms of learning. And the obvious question would say, well, if you have the expert, why do you need a machine? Like Fernand said. Well, you don't need the machine for the cases that you look at now, but for subsequent cases, you're not going to call an expert every time to come back and look at those examples, that new examples that you haven't seen before. So you want to learn from before, update your parameters, and hopefully do a classification which is based on a better understanding of context given by the experts. So that would be my take on this.
I was thinking of something a little different. Could it be that this machine translation works very well for technical reports, for standard text, for medical issues, but that it will never work as well for creative writing, for poetry, for things in which disrupting these
absolutely
parallels that you're talking about are what make it creative.
Yep.
And therefore we really have to think about selectively applying.
I would agree with you fully.
And continuing to train expert translators.
Yes.
Not doing away with the profession, which is what I really think we need to be concerned about.
Yes, it is. I wish the. I mean, you could see also from the results when you compare the medical data sets with the narrative or the fictional narrative. The difference is horrendous. It was 70% for one, over 90 for the other. So that tells you something already. And yes, as a creative writer, I would like to use words in a different way, and that will, for a machine, unless it knows that, it's going to give you a different translation, whatever you do. But again, how many are from the general audience would even get what the intent is, let alone leave alone machine translation on their own when you start in poetry or otherwise. So the journey is we're going. It's the beginning of the journey. We're not at the end of it by any stretch of the imagination, not at all.
Whoa. No. Yeah, and we can have because it's 2.
Oh, okay.
15 minutes.
We can talk about